In this video, I will explain you about bit merging and bit masking. These are performed using bitwise operations. So this is one of the application of bitwise operation. Let us understand what does it mean. Here I have one variable of type byte a, which is having value 0. Byte takes 8 bits. So I have shown all 8 bits here from right hand side, starting with bit index as 0, 1, 2, 3 up to 7. So total 8 bits are there and all of them are 0. These are all binary bits. See, we know that every binary bit can be either 0 or 1. So for 0 we can make out some meaning, and for 1 we can make out some meaning. Like for 0 I can say no, and for 1 I can say yes, or even I can say false for 0 or true for 1, or it can be absent or present. So there are many situations where we come across we have to store either 0 or 1. So even we have a Boolean data type for this one in Java, so where we can have true or false values. But if you want array of such values, then you can also use bits of a variable. So we can mark each of these individual bit as 0 or 1, and also we can check whether a bit is marked as 0 or 1 with the help of merging and masking. Let us understand this through an example. Let us assume that there are 8 students in a class, and the first student roll number is 0 and the last student roll number is 7. Now this zeros represent that all of them are absent. Now I want to say that roll number 3 is present. So I want to mark this as 1. So how to make it as 1? This bit as 1. I want to make this bit as 1. So under this I will write this as 1, and these are all zeros. These are all zeros. So for this I will take another variable, let us say b. So what is the value? A decimal equivalent for this one is 8. This is 2 power 3, 8, right? So this is 8. So a is actually 0 and b is 8. Now if I perform merging a or b, so what is the ORing result? 0 or 0 is 0, 0 or 0 is 0, and this is also 0, 0 or 1 is 1, and this is also 0, this is also 0, all these are zeros. So this has become 8. So I will put it in A. So this is how, by performing OR operation, I can make any one particular bit inside a byte as 1. This process of setting one of the bit as 1 is called as merging. Now let us change this. I'll make this as 1. Now let us try one more. I want to make this student roll number 6 as also present. So I will remove this. So I made A as 8. Now I said I want to set this as 1. So rest of them should all be 0. Rest are all zeros. Okay. So what is this value? This is 2 power 6 is 64. So this b is 64. Now if I perform a or b, so a or b, so a is already having 8. So when I perform OR, so let us do it from right side. This is 0 or 0, 0 or 0, 0, 1 or 0 is 1, and this is 0, this is 0, 0 or 1 is 1, and this is 0. So a or b has given me a new number. You can see that inside a, if I store it in a, for a, this bit 6 as well as bit 3 both are on. So I am able to set a particular bit of a number as 1 by performing merge operation. And while performing, I am having a number in which already that bit is set on. Now I will show you how to find out whether a particular bit in a number is on or off. So I will remove this first. I want to find out whether this bit is on or not, whether it is 1 or 0. So this is the 4th bit from right side. So for finding out whether this is on or not, I will take b, and in that I will set this value as 1 and rest of all of them as zeros. Rest are all zeros. Now what is this value? This is 8. Right now a is not 8. 8 is 64 plus 8, that is 72. Now With A and B, I will perform AND. A and B. And let us see the result. 0 and 0, 0, 0 and 0, 0. This is also 0. This is 1. And this is 0. This is 0. This is 1 and 0 is 0. And this is also 0. So now the result is how much? 8. So this value is greater than 0. This is greater than 0, right? I got 8. It is not 0. So it means this bit is on. This bit is on. So after performing 8, if you are getting a result that is greater than 0, means that bit is on. Let us change the bit and show you. I want to check whether this fourth bit is on or not. So this should be 1 and this should be 0. This is 2 power 4 is 16. So this is not 8. This is 16. Now let us perform AND operation. 0 and 0, 0 and 0, 0 and 0. 1 and 0 is 0. 0 and 1 is also 0 and all others are 0 only. Now you can see that this result is 0. So if you got the value that is equal to 0 means that bit is not set on in A, inside A. This is how you can perform merging by using OR operation, by setting any bit as on, and you can know whether this bit is on or not by performing AND operation, and it is called as masking. So you are masking means you are hiding all the bits and you are looking at only particular bit or one or more bits also you can check, not just one bit. Now let me show you one more application of bitwise operation. Suppose I want to store numbers from 0, 1, 2 up to 10. I don't have any number beyond 10. So for storing numbers from 0 to 10 only, how many bytes are enough? 1 byte is more than enough. But is it possible in storing in less than 1 byte? So 10, if you see the binary form, it is 1010. So in binary form, it requires only 4 bits. 4 bits. Yes. So I don't need 1 byte also. I just need 4 bits. So 4 bit is also called as nibble. So just 1 nibble is enough. So is it possible to declare a variable of type nibble, that is 4 bits? No, it is not possible. Then how I can utilize only 4 bits? So I can declare a variable of type byte. Within that, I can use first 4 bits for one number and next 4 bit for another number. So in this way, I can store 2 numbers within a single byte variable. So 1 byte variable can have 2 numbers. So how it is possible? So I want to store 2 numbers in these 2 places. Let us take first number as, I will take a number. Right now A is 0, right? I want to store 5. So first of all, I will store 5. So binary form of 5 is 1, 0, 1. And rest all the bits are zeros. Now this is A, which is having all zeros. This is B, which is having 5. Now how to store this 5 inside A? So we know merging, perform OR operation and store the result in A. So the new A value becomes 0, 0, 0 and these are all zeros and this is 1, 0, 1. Now I have used these 4 bits for storing 5. Now I want to store 9 in these 4 bits. So how to do that? So I will change this first of all. I will change this A and I will remove and show you. You know, inside A, in these 4 bits, I have 5. Now in this 4 bits, I want to store 9. So B is 9. So first of all, I will write B in binary form. That is 0, 0, 0, 1, 0, 0, 1. So if I perform any operation with A, then these bits will be modified. I want this 9 on this side here. So I should move these bits on the left hand side. So perform left shift on B by how many digits? 4 digits on the left hand side and store it in B only. So this will become 4 places it will move. 1, 2, 3, 4. So 1 comes here, then 0, then 0, then 1 and these are all zeros. So this is how this number has shifted on this side. So this became 1, 0, 0, 1, 0, 0, 0, 0. Now perform ORing with B, A or B. So now the result will be inside A if you take. So this will be 1, 0, 0, 1. See, I'm not taking this one. I'm performing ORing with this one, right? So this is 0, 1, 0, 1. So these first 4 bits are 5 and these 4 bits are 9. So this is how you can store. Now same way, by using AND, you can find out what is the number in that one. So this is about merging and masking. So how to take out these numbers by using AND, that is masking, I will show it in a practice video. Let us look at one more application of bitwise operation using XOR operation. See, by using XOR operation, we can swap two numbers without using a third variable. So let us see it through example. I have two numbers, A is 9 and B is 12. So I have taken 1 byte of binary digits. So this is 9 for A and this is 12 for B. Now, how we can swap the numbers? So I will show you the steps, then I will show you the results also. See, first of all, perform A XOR B and store the result in A. So what is A XOR B? Here I will perform it. XOR means if both the bits are 0 or both are 1, then the result is 0. Otherwise it is 1. So 1 XOR 0 is 1. 0 0 is 0 and 0 XOR 1 is 1. And here 1 XOR 1 is 0 and rest of all 4 are 0 only. So this is a new value that is actually equal to 5. This is the new value we got. So this is 101. So this will be stored in A. So now A will change to 101. So this becomes 1 and this becomes 0, right? So I will change them here. Now A has become 5. I have modified it. Now next step. Inside B store A XOR B again. So perform same thing but store the result in B. So let us perform XOR. 1 XOR 0 is 1. 0 XOR 0 is 0. And 1 XOR 1 is how much? 0. And this is 0 XOR 1 is 1. And leading all 4 bits are zeros. So this is a new value. This is how much? This is 9. So B becomes 9. So in B, this becomes 0 and this becomes 1. So A is a 5 and B became 9. Now let us look at next step, but before that I will modify this B and I will make it ready for the next step. Now A is 5 and B is 9, 1001, right? Now again perform A XOR B and store the result in A. Let us do it once again. XOR 1 XOR 1 is 0 and this is 0 0 is 0 and 1 0 is 1 and 0 1 is also 1 and leading 4 bits are all zeros. So this we got 12. So 12 will be stored in A. So this A becomes 1100. This will be changed. So now A became 12 and B became 9. So by using these three steps, so values can be swapped without using third variable or temporary variable. So the value of A has gone into B and the value of B has came into A. And one more important thing I will tell you about XOR operation. When you perform A XOR B, so where A is 9 and B is 12 in the beginning, right now suppose they are 9 and 12, then the result will not be greater than 12. Means the result will not be greater than the maximum of these two numbers. So one of the number is 12, so the result will be definitely less than 12. So that's all about applications of bitwise operations. So in the next video, I will perform all these operations and show you as a practice. So and I suggest you also do it by yourself. Write a program and try all these things. It is just like experiencing all these things so that you can easily use them in right place in your programs.